Hello, how are you? Today we'll talk about a relationship that exists between the concepts of entropy in physics and some other concepts that were developed in philosophy, particularly speaking, developed by the philosopher Ludwig Wittgenstein back in the 20th century. And these concepts are about the idea that we can have different terms in different theories, and these terms can have different properties and different meanings. And we can create a net that is a structure that shows these common properties of these concepts, and we can connect these concepts with each one of them. And although these concepts are essentially the same, we can have a particular property that we can use to distinguish each one of them. We can apply this theory that Wittgenstein called languagegame theory in a lot of fields of knowledge, but I will show how we can apply in the case of physics, particularly speaking, in the case of the concept of entropy. Well, historically speaking, the concept of entropy was first developed by the scientist Rudolf Clausius in 19th century. And was developed in the context of his studies about the Carnot cycle. And you should know that the Carnot cycle has many applications in the fields of engineering and physics, and is about relation of temperature and heat. And temperature is a quantity in physics that we can measure directly. And heat is related to energy, and energy is not a quantity that we can measure directly. And this relation of heat and temperature, that we call the entropy. And the entropy is a very general concept. It's more related to energy. That is another example of another general concept. And later, a new concept of entropy has emerged. That is the concept that was developed by the scientist Ludwig Boltzmann, and is a statistical, and is about a statistical approach of the concept of entropy. And this new concept relates the microscopic states that we call microstate of a thermodynamical system. A relation about this concept, these microstates, with a macro state of a classical thermodynamical system. That you should know that this macro state we can describe by classical quantities like temperature, pressure, volume, and so on. A generalization of the Boltzmann entropy has emerged and was developed by the scientist Gibbs. And this new concept of entropy is about open system. And the Boltzmann entropy is about isolated, a closed system. And the Boltzmann entropy is defined as the logarithm of the number of microstates that are related to a macro state of a system. And the Gibbs entropy is about, for example, two systems that can interact thermically and can exchange thermal energy by heat. And the Gibbs entropy has a different meaning in physics, and is about the sum of probabilities that all of these microstates can have. And all of these three entropies have different meanings in different theories of physics. And how can we apply the theory that was developed by the philosopher Wittgenstein? As I said, it's about the languagegame theory. Well, all of these concepts of entropies have different meanings in different theories, but they have essential property. And this property is described by the second law of thermodynamics. There are four laws of thermodynamics: the zero law, the first law, the second law, and the third law. And the second law of thermodynamics describes the increase of entropy in isolated systems over time. And all of these entropies obey the second law of thermodynamics. And we have a new generalization that was proposed by the scientist Constantinos Sales, and is a generalization of the Gibbs entropy. This entropy has a different meaning, and also obey the second law of thermodynamics. And in all of this case we have a very clear application of the language game theory of Wittgenstein. And we can create a net that we can put all of these concepts of entropy together, and we can analyze which properties these concepts have in common, and some other properties that these concepts can have. This shows that the concept of entropy is a very broad concept, and an example that is often cited in the case of the language game theory that Wittgenstein called familiar resemblance is the chess game. In the traditional chess game, the king, for example, can move only one time, but in all directions. In another chess games, you can have different rules, and the king can move for example, to a specific direction. And the essential property of these chess games is that all of these chess games can be played on a board, and that is the essential property. And in the case of entropy, as I said, all of these concepts of entropy can be used in different theories, but all of them obey the second law of thermodynamics. That is what these concepts have in common. And another example of a concept in physics that also can be described by the language game theory of the philosopher Wittgenstein is the concept of energy. You know, we can have different concepts of energy in physics, and the kinetic energy, for example, the potential energy, the thermal energy, and another examples. All of these concepts of energy obey the conservation law. That is a famous law in physics. And another example of a quantity that can be described by this theory of the language game theory is the concept of field. All of this, and we are amazing to say that this last generalization that was proposed, like I said, by by Constantinos Sales, that is the generalization of Gibbs entropy, and Gibbs entropy is a generalization of Boltzmann entropy. We are amazing to say that this entropy also obey the second law of thermodynamics, and this has been confirmed along the years. And the entropy, like energy, field, and some other properties in physics, are very general properties. And I will show in another videos how we can relate another properties in another fields, not only in physics but in philosophy too. And I was forgetting to say that Wittgenstein had studied the works of Boltzmann and another scientists, and apparently he didn't conceive a relationship about his own theory and the concepts that were developed by the scientists, the concepts of entropy. Thanks for watching this video, and I hope that the content of this video can be useful to you.